the fourth property. At least one eigenvalue of A. This is one time in GATE ask directly statement. Singular matrix. What is singular matrix? That is determinant A equal to 0 is 0. So whatever the matrix, if it is singular, that means det A 0. Definitely one of the eigenvalue, minimum one eigenvalue is 0. Okay. Next, E values of a non-singular matrix. That is, non-singular matrix means determinant A not equal to 0 are all non-zero. Just without example, by conceptual way I am explaining. Logical method, that is called. What is det A 0 means? You know determinant procedure. What is determinant A from first property? Product of eigenvalues. So for a given matrix, the determinant is now new definition product of eigenvalues. Eigenvalues means numbers. Product of numbers equal to 0 means compulsory one number 0. Do you think that product of non-zero numbers 0? So when you are finding the product for a given numbers, if the answer is 0, definitely one of our number is 0 or not, logically. Okay. Now, det A not equal to 0. That is called non-singular matrix. Without finding eigenvalues, you can use this property. Determinant A is nothing but from first property, product of eigenvalues. Eigenvalues means some numbers. Product of numbers not equal to 0 means each number is not equal to 0. No. Product of numbers, given numbers is not equal to 0 means that means each number is a non-zero number or not. That means all eigenvalues of a non-singular matrix are non-zero. That is simple. Next, number 5. If lambda is eigenvalue of matrix A, then this property, just logical way I am explaining, correspondingly you follows. What is correspondingly mean? If I change the power of lambda or notation, I mean or inverse of lambda is 1 by lambda, the correspondingly matrix also changes. Okay. Lambda square is an eigenvalue of matrix A square, comma, lambda cube is an eigenvalue of matrix A cube, so on. Lambda power m is eigenvalue of matrix A power m. This is called correspondingly. Okay. Next, when you multiply a number to this eigenvalue, that is called k lambda. K is a scalar, is eigenvalue of matrix correspondingly k into A. Okay. Next, f of lambda, that is polynomial in lambda, is E value of matrix f of A, where f of A is polynomial in A. Next, lambda plus or minus k whole power m is eigenvalue of matrix A plus or minus k into I, identity matrix whole power m. Next, 1 by lambda is an eigenvalue of matrix A inverse. And finally, det A by lambda is eigenvalue of adjoint A So whatever lambda changes its position, accordingly matrix also changes. Polynomial in A means, polynomial in X means x square plus x plus 1, x cube plus 3, x square plus x plus minus 1, etc. Polynomial in A means the powers of the matrix A is a natural number, a square plus 2a plus a. Okay. For example, a matrix 2 by 2 matrix has eigenvalues 1, 3. Find the eigenvalues of the matrix A square plus 3a plus 4i without finding a square 3 into a. So you can just substitute the matrix A by correspondingly lambda. This is for polynomials. And here also, it is a polynomial expanding this. Okay. Lambda inverse is 1 by lambda. Matrix A inverse is A inverse. Correspondingly, it follows. A inverse formula, first day, what is that? Adjoint A by det A. So the denominator det A shifting to left side becomes det A by lambda. In the last step, 1 by lambda. This A inverse is adjoint A by det A. Shift this det A to the right side. Mathematically or logically, you will get this property. Okay. Number 6. So whenever matrix changes, eigenvalue also correspondingly changes. But in case of vectors, A and A square have same eigenvectors. Take a 2 by 2 matrix, find all eigenvectors, find A square matrix, again find eigenvectors. So whatever the eigenvectors obtained from A square, which are same as eigenvectors of matrix A. Similarly, A and A cube have same eigenvectors. A and A inverse have same eigenvectors. A and K into A. K into A means K is a number. What is K into A? Every element of the matrix A multiplied by K. Again, getting same eigenvectors. Okay. So matrices A and A square, comma A cube, so on, A power m, comma f of A, comma K into A, comma A plus or minus K whole power m, comma A inverse, comma adjoint A have same E vectors. This is first type of properties, asked many problems on these properties. Similarly, second level properties, 4 to 5 properties, which are asked previously, direct statement questions only. Okay. So if you do not remember these, if you feel difficult, then just take 2 by 2 matrix. You only prove it, will satisfy and will take less time only. And one more property I am going to discuss. After that, I will start problems. Okay. Seventh one, E values of an idempotent matrix A. That is, yesterday I told you, day before yesterday, A square is equal to A. Or just, I will tell the logic, how to remember this. Lambda satisfied by this equation, eigenvalue, square of which number is equal to itself? 1 square is equal to 1. Correct or not? Minus, 0 square is equal to 0. Only two types, idempotent matrix. Either 0 or 1 or both. 0 or 1 or both. E values of involuntary matrix. This question related to 2014. A. Involuntary matrix yesterday, day before yesterday, A square is equal to I. Or I means identity matrix. Comparing with numbers, I value is 1. Eigenvalues of identity matrix 1 or not? So square of which number is equal to 1? 1 square is equal to 1. Minus 1 whole square is also plus 1. So 1 or minus 1 or both. E values of nilpotent matrix. That is, A power n is equal to 0. So this question asked directly last year, 2 years back, 2018, are all 0. Why all 0? So which number satisfying this equation? 0 power any positive integer. N value, index means positive integer only. 0 power 1, 0 power 2, 0 square, 0 cube is equal to 0. Is there any non-zero number to the power any number giving 0? So that's why for nilpotent matrix 2 by 2, 3 by 3, any nilpotent matrix, solve eigenvalues. Definitely all lambda values equal to 0. Next, number 8. E values of a real symmetric matrix or Hermitian matrix are all real. This one asked 2014, 15, so many sets, so many branches asked. Next, E values of a real. What is real symmetric means? Symmetric means A transpose is equal to A. What is real matrix? First day I told you. Every element of a matrix A is real number. Such matrix is called real matrix. Otherwise, the matrix is called complex matrix or imaginary matrix. Real, skew, symmetric matrix. SYMM means symmetric matrix or skew Hermitian matrix. Or 0 or purely imaginary or both. What is purely imaginary means? I told you I minus 3i, I by 2, etc. Okay. In this last condition, E values of a real orthogonal matrix or unitary matrix or of unit modulus. What is unit modulus means? Modulus of that eigenvalue 1. Modulus means is a positive quantity. When you get negative values, mod lambda becomes positive. So in that case, mod lambda value 1. That is, have an absolute value 1. Tomorrow we will discuss this absolute value meaning modulus of a real number that will come in the basic definition of calculus chapter. Absolute value. So please go through in that order by heart. In this 8th property, if I do not explain by an example, you only take yesterday's symmetric, skew symmetric, orthogonal, some 2 by 2 matrix example provided. So you know how to find lambda values from the characteristic equation. You only check this one. See, today first problem, 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. First row equal to first column, second row equal to second column, third row equal to third column. That is, A transpose is equal to A. So, this is all the 9 elements real numbers. So, real matrix as well as symmetric. Real symmetric matrix. What we got? Lambda values 0, 3, 50. So, all real numbers are not. That is this. Next. Day before yesterday I told you orthogonal matrix 0, 1, 1, 0 is orthogonal matrix. And all 4 elements real numbers. So, real orthogonal matrix. So, what is characteristic equation? Subtract lambda from the diagonal elements. Lambda square minus 1 is equal to 0. Lambda square is equal to 1. Implies lambda is equal to minus 1 comma 1. Minus 1 whole square plus 1 plus 1 square 1. So, for both, if you find modulus, mod minus 1 is equal to plus 1. Mod 1 is equal to 1. That is this. Similarly, you can check skew symmetric, that example also. Either 0 or purely imaginary or both. Like that you considered all these definitions with example provided long back. Don't worry, you need not worry about this. And sometimes also I may test your problems, practice purpose given by me, correct or not, doing or not. That's why sometimes I am giving silly mistakes last step answer for practice purpose. So many students you are trying, almost 99% students trying very good. Daily you have to practice like this. Definitely you will crack your GATE exam. Okay. Example 1. (2016). The condition for which the eigenvalues of the matrix A is equal to 2, 1, 1k are positive, comma, is A k greater than half, B k greater than 2, C k greater than 0, D k less than half. Solution. So, a 2 by 2 matrix definitely having 2 eigenvalues. That both eigenvalues given positive. Okay, let us see. Since E values of A 2 cross 2 are positive. This is the symbol I am using. Plus VE stands for positive. Therefore, det A is equal to what is that? Product of eigenvalues using property 1. Okay, refer that. So that means when when the given numbers are positive, their product is also positive. So given numbers means here eigenvalues. Here the 2 eigenvalues are positive, so their product is also positive. Is also positive. So that means determinant A positive, that symbolic form, that is inequality, greater than 0 or not? Negative means less than 0 or not? What is det A? Which is a 2 by 2 matrix determinant. 2k minus 1 greater than 0. Shift minus 1 to right side. K greater than half. Therefore answer is option is A. Since determinant A, B, C, D is equal to AD minus BC. Number 2. Two 2017. Given that a 5 cross 5 matrix A is equal to 1, 2, 3, 4, 5. 5, 4, 1, 2, 3, 4. 4, 5, 1, 2, 3. 3, 4, 5, 1, 2. 2, 3, 4, 5, 1. 5 by 5 matrix has only one real eigenvalue, full stop. The real eigenvalue of A is options A minus 2.5, B 0, C 15, D 25. See, 5 by 5 matrix having 5 eigenvalues. If you go by using the method, definition method of characteristic equation, it takes more time. Sometimes it is unable to solve that lambda power 5 equation also. Tough task. In that case, property is helpful. Just observe every row elements just by changing the position only. But the same 5 numbers 1, 2, 3, 4, 5. So sum 1 plus 2 plus 3 plus 4 plus 5, which gives 15. 15 is a real number. So already given A has this 5 by 5 matrix only one real eigenvalue. Automatically remaining 4 eigenvalues are imaginary. So we got sum of the elements in every row is equal to 15. Similarly, columns also satisfied. I can use property 2. Since sum of all entries, that is elements, in each row or column or both is equal to 15. This 15, where I highlighted by blue color, is real number or not. And A has only one real E value. Moreover, you can depend on the options. There is an option C directly, 15. Okay? Therefore, the real E value of A is 50. This question from 2016. Let the eigenvalues of a 2 cross 2 matrix A be 1 comma minus 2 with eigenvectors x1 and x2 respectively, then the E values and E vectors of the matrix A square minus 3A plus 4I respectively be options 2 comma 14 x1 comma x2, option B 2 comma 14 x1 plus x2 comma x1 minus x2, 2 comma 0 x1 comma x2, 2 comma 0 x1 plus x2 comma x1 minus x2. Just please remember that properties. So please refer property number 5 and 6, all of you. Solution. Let lambda is equal to 1 minus 2 be the E values of the matrix A 2 cross 2. This is given, but I denoted by lambda. Implies E values of matrix A square minus 3A plus 4I. This is looks like f of A, polynomial in A. Refer that property 5, or lambda square minus 3 lambda plus 4. That means this is f of lambda. Okay, since property 5. So substitute each lambda, that is 1 square minus 3 into 1 plus 4, and substitute minus 2 whole square minus 3 into minus 2 plus 4, which is simplifies to 1 plus 4, 5 minus 3, 2, 4 plus 6 plus 4, 14. 2 comma 14, which are in 2 options. So 2 options are neglected. So we have to decide either A or B answer. Next. Eigenvectors of matrix A square minus 3A plus 4I. Again polynomial in A and A square, A and A cube, etc. A and f of A and A inverse, A and adjoint A. Refer property number 6, have the same eigenvectors. Or x1 comma x2 since property 6. So answer accordingly option A. Fourth one, this question asked in 2014. The matrix A satisfying the equation matrix A into matrix 1, 2, 3, 7, 8, 9, 4, 5, 6 is equal to matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, the eigenvalues are option A 1 minus I comma I, option B 1 1 0, option C 1 1 minus 1, option D 1 0 0. Solution. Just observe on both sides, only one row, two rows are interchanged. So, when two matrices are equal, left side product of two matrices, but we don't know A is not given, which finally automatically a matrix only, because all options 3 eigenvalues. So, definitely A is a 3 by 3 matrix. So, when both sides you have matrices, both are equal, corresponding determinants are equal. When A is equal to B, automatically det A is equal to det B. So, taking determinant on both sides of the equation, we get determinant bracket A into bracket 1, 2, 3, 7, 8, 9, 4, 5, 6 is equal to right side 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I am doing, apply R1 interchanges R2 on RHS determinant. DET means determinant, RHS means right hand side. Now left side looks like determinant of product of two matrices. Say this is B. Det AB, the beginning day, first day, det A into det B. So that means det A into determinant 1, 2, 3, 7, 8, 9, 4, 5, 6. In the right side, if you interchange two row operations, determinant will be affected by sign only. So plus becomes minus into determinant 1, 2, 3, 7, 8, 9, 4, 5, 6. From this, shift this right hand side negative determinant to the left side. You will be getting det A plus 1 after taking the common determinant det 1, 2, 3, 7, 8, 9, 4, 5, 6 is equal to 0. So determinant is a number, this determinant is a number. Product of two numbers equal to 0 means either of these number equal to 0. But we don't want any interest on this. This should be ignored because the question asking eigenvalues. So from this is not A matrix, this is. So from this, determinant A plus 1 equal to 0. From this, determinant A is equal to minus 1. But we don't get eigenvalues. We got finally determinant A is equal to minus 1, which implies product of E values is equal to minus 1 since property 1. What is today property 1? Eigenvalues, product of eigenvalues. So some problems whose solutions we should depend on option wise. We should proceed option wise. So which option we got or we are getting product of the numbers equal to minus 1. I square value first day I told you. So this product of these three numbers plus 1 getting. Product of these three numbers in option B is 0. In option C, product of three numbers is minus 1. In option D, product of three numbers is 0. All the three numbers in each option, let us denote eigenvalues. Whichever satisfy product is equal to minus 1, that option is the answer. So, what is our conclusion? Answer is option C. Therefore, only in option C, product is minus 1. So answer is option C. Fifth one, this question from 2016. The eigenvalues of A is equal to 2, 1, 1, 2, 3, 4, minus 1, minus 2, or 1, minus 1 and 3. The trace of matrix A cube minus 3A square is dash. So already let eigenvalues given denoted by lambda 1, minus 1, 3 be the E values of matrix A3 cross 3. So first concentrate which matrix we are finding trace A cube minus 3A square. So just I want to find eigenvalues of that A cube minus 3A square. Implies E values of matrix A cube minus 3A square or lambda cube minus 3 lambda square, since property 5, this is polynomial in A. So this, if you denote f of A matrix, A is replaced by lambda, f of lambda. Now that is, substitute each 1 by 1 lambda from the first step. Here 1 cube minus 3 into 1 square. Next, minus 1 whole cube minus 3 into minus 1 whole square. And finally, substitute 3 cube minus 3 into 3 square. So you will be getting, that is minus 2. This one minus 3 minus 1 minus 4. And this one 3 cube minus 3 into 3 square, 3 cube, simplifies to 0. So these are eigenvalues of the matrix A cube minus 3A square. But the question related to trace of any matrix is nothing but sum of the eigenvalues or not. Refer property 1. Therefore, trace of A cube minus 3A square is sum of E values of matrix A cube minus 3A square. Since property 1. So what is the sum means? Minus 2 plus minus 4 plus 0 is equal to minus 6. Sixth question, 2016. Suppose that the E values of matrix A are 1, 2, 4, full stop. The determinant of A inverse whole transpose is dash. Solution. Let lambda is equal to 1, 2, 4 be the E values of matrix A. So, determinant A inverse whole transpose is nothing but determinant A inverse. Yesterday, determinant A is equal to determinant A transpose. That is first day properties. Determinant A inverse is nothing but 1 by det A. 2015 problem in the first day also I have done. Today, determinant A is product of the eigenvalues. 1 by 1 into 2 into 4 is equal to 1 by 8. Since property 1, comma, det B transpose is equal to det B, and det inverse of a matrix is nothing but 1 by det B. These are the points I use in this problem. Seventh one. This question asked in 2015. The value of x for which all the e values of the matrix A is equal to 3 by 3 matrix 10, 5 plus I, 4, x, 20, 2, 4, 2 minus 10 are real is dash. Numeric question. Solution. Since all e values of matrix A are real, so just refer property number 8. Therefore, A is real symmetric matrix or Hermitian matrix. So just underline real symmetric. What is real symmetric? A transpose is equal to A. Real matrix means all elements are real numbers, but one of the element is complex number, imaginary. Okay. Since one element, that is 5 plus I, is not real, therefore A is Hermitian matrix only. What is Hermitian matrix definition? A power theta is equal to A. That means A conjugate transpose is equal to A. Am I correct or not? So, you know conjugate and then transpose. 10 will become here x bar after transpose. We don't know x value, that's why I put conjugate of x, that is x bar. 4 conjugate is 4. 5 plus I conjugate is 5 minus I. 20 conjugate is 20. 2 conjugate is 2. 4 conjugate is 2. 2 conjugate is 2. Minus 10 conjugate is 1. That means I have done 2 steps at a time. Conjugate and then transpose. Because both are easy. In the first day I told you many examples. Is equal to A. What is A? 10. 5 plus I. Given matrix 4. X. 20. 2. 4. 2 minus 10. When two matrices are equal means corresponding elements. See, I can equate these two. Fourth element equal to fourth element. Therefore, x is equal to 5 minus I. It's not numeric question. It is options, but time waste if I provide options. These are the different types of problems. Please go through seriously. So here, what is the property number? Since property 8. In the problem itself is given all eigenvalues are real numbers. So there are only two possible, either real symmetric matrix or Hermitian matrix. But one of the element is already complex number in the matrix. So that's why this matrix is not a real symmetric matrix. Definitely it will become Hermitian matrix. And refer Hermitian matrix definition, first day. So just 2 to 3 remaining properties continued. We already discussed 8 properties, now 9. This question asked related to 2017. E values E vectors corresponding to distinct E values of a real symmetric matrix are orthogonal vectors. What is orthogonal vectors in the first day? Implies dot product is 0. 10. This question asked in 2018. E vectors corresponding to distinct E values of any matrix are linearly independent. Here real symmetric, here any matrix, here distinct. Okay. Now 11. A and A transpose have all these 9 and 10. I have done today first problem 3 by 3 real symmetric matrix. You can cross check. Orthogonal vectors means dot product 0. I already found 3 eigenvectors. Please check according to the first day class and today properties. And similarly remaining also take a 2 by 2 matrix. Check these things. Same eigenvalues but have different eigenvectors. Okay. The last one, the constant term in the characteristic polynomial of matrix A is equal to determinant of that matrix. This is also you can check. Characteristic polynomial, I told you. Remove equal to 0. Det A minus lambda I. Take a 2 by 2 matrix. Find determinant A minus lambda I, which gives characteristic polynomial. In that, the constant term is same as equal to determinant of that matrix. All these properties saving the time without solving lambda values, finding lambda equation, etc.